Namaskar. Welcome to Sai Economics Point. In today's lecture, we will discuss mathematical derivation of Slutsky equation part 2. Now, rewriting equation number 4, 5 and 6 together we will get uxx dx, okay, plus uxy dy minus px d lambda equal to lambda dpx, which is your equation number 4, okay, and uyx dx plus uyy dy, okay, minus py d lambda equal to lambda dpy, which is your equation number 5, okay, and next minus px dx, okay, minus py dy equal to your minus dm plus x dpx plus y dpy, which is equation number 6, okay. So this equation we can also write as minus px dx minus py dy plus 0 multiplied by d lambda equal to minus dm plus x dpx plus y dpy. By rewriting this, there is no change in the equation, okay. So now we will write the coefficient of the variables dx and the coefficient of a variable dy and the coefficient of a variable d lambda and the constants in one side, okay. So we'll put these equations in the metric notation as uxx uxy minus px uyx uyy minus py minus px minus py 0, which is nothing but the coefficient matrix and it is denoted by a multiplied by dx dy d lambda. This is nothing but your variable matrix and is presented by x, and this is equal to your constant, that is lambda dpx lambda dpy minus dm plus x dpx plus y dpy, which is nothing but the constant matrix and is represented by b, okay. See, by inverse method we can write as x equal to b, a multiplied by x equal to b, and we can also write x equal to b by a, okay, and x equal to a inverse into b, okay. Now a inverse equal to, the formula is adjoint of a, okay, divided by determinant of the matrix, okay, and adjoint of a is equal to transpose of a cofactor of a, okay. So now, okay, cofactor let cofactor of a, okay, is equal to d11 d12 d13 d21 d22 d23 and d31 d32 and d33, okay. So, what is D11? D1 is the cofactor of a UXX, okay, and D12 is the cofactor of a UXY, okay, and D13 is the cofactor of a minus PX, D21 is the cofactor of a UYX, okay, and D22 is the cofactor of a UYY, and D23 is the cofactor of a minus PY, and D31 is the cofactor of minus px, D32 is the cofactor of minus py, D33 is the cofactor of 0, okay. Now let's see how to calculate the cofactor of okay, D1 1, okay. So cofactor, okay. So now we will calculate which is the cofactor of uxx, okay, which is represented by d11, okay. So uxx equal to, see, uxx equal to, okay, minus 1, okay, to the power 1 plus 1, okay, and this column and this row is deleted, uyy multiplied by 0 minus py minus py, okay. So cofactor of ux equal to, we can write minus 1, okay, to the power 1 plus 1, okay, multiplied by uyy, okay, uyy into 0 minus py minus py, okay. So this equal to your, Okay, this becomes positive and this is 0, and this becomes finally your minus, okay, p, okay, p y square, okay, py square. Okay, the next cofactor cofactor of uxy. Okay, next we'll calculate cofactor of a uxy. Okay, so here equal to, okay, this equal to minus 1. Okay, we are calculating the cofactor of a uxy, that is, okay, d12, which is represented by d12. So this equal to minus 1 to the power 1 plus 2. Okay, and this row, this column deleted, and this is multiplied by uyx into 0 and minus py into minus px. So right here, so this equal to u, okay, uyx multiplied uyx into 0 multiplied by minus py minus px. Okay, minus px minus py. So this equal to, this becomes your minus 1 to the power 1 plus 2. Okay, so this becomes odd, so we'll get minus 1. Okay, so here we'll get minus 0 minus px py. So this equal to px py. Okay, now, okay, now we'll calculate. So now we'll calculate the value of a d13, okay, which is the cofactor of a minus px. So d13 equal to d13, which is the co which is the cofactor, okay, which is the cofactor of minus px. So this equal to minus 1 to the power 1 plus 3, 1 plus 3. Okay, so see, we are calculating the cofactor of a minus px. So this row, this column deleted, and it is multiplied by yx into minus py minus px into uyy. So this equal to here uyx minus py, okay, and minus px uyy. Okay, so this equal to here, so this becomes your even number. Okay, 1 plus 3 equal to 4 minus 1 to the power 4, this becomes positive. So this equal to here minus uyx into py, okay, minus uyy px. Okay, so this equal to, taking minuses common, this becomes py yux plus px uyy. Okay, now we will calculate the value of a d21. Okay, d21, which is value of a, so we will calculate the value of a d21. Okay, that is cofactor of uyx. Okay, cofactor of a uyx. Okay, so this equal to minus 1 to the power 2 plus 1. Okay, we are calculating cofactor of this, so this row, this column deleted. So minus 1 to the power, okay, 2 plus 1 multiplied by uxy into 0 minus py minus px. Okay, so right here, so this equal to uxy multiplied by 0 minus py minus px. Okay, so this equal to your minus 0 minus py, okay, px. So this equal to your py px, or you can write px py. Okay, next, cofactor of uyy, that is t22 equal to minus 1 to the power 2 plus 2, okay, into, okay, into uxx into 0 minus px into minus px. Okay, so this equal to your minus px square. Okay, next, cofactor of a minus py. Okay, cofactor of minus pi is your d23, okay, which is equal to, okay, this row, this column deleted, okay, that is minus 1 to the power 2 plus 3, okay, into uxx minus py minus px into uxy, okay. So this equal to your uxx into py minus uxy px, okay. The next your cofactor of minus px, okay, cofactor of minus px equal to d31, okay. So this equal to minus 1 to the power 3 plus 1, okay, multiplied by uxy minus py minus uyy minus px. So finally we will get minus uxy py plus uyy px, okay. The next cofactor of a minus py, okay, cofactor of a minus py equal to, okay, so minus 1 to the power 3 plus 2, okay, into uxx minus py minus uyx minus px, okay. So this equal to your uxx py minus uyx px, okay. Then the last is cofactor of a 0, that is d33, okay, is equal to minus 1 to the power 3 plus 3 multiplied by uxx into uyy minus uyx uxy, okay. So finally we'll get uxx uyy minus uyx x uxy, okay. Now okay, adjoint, now adjoint of, okay, adjoint of a equal to, okay, now adjoint of a equal to, okay, transpose of a cofactor of a, okay, transpose of cofactor of a, okay. So this equal to cofactor of a, as we know, d11, d12, d13, okay, d21, d22, d23, d31, d32, d33, okay, transpose, okay. So transpose of any matrix means rows becomes columns and columns becomes rows. That means d11, d12, d13, this is the first row. The first row becomes first column, second row becomes second column, third row becomes third column, okay. And first row becomes first column, second column becomes your second row, third column becomes third row. So this equal to your d11, d21, d31, okay, d12, d22, d32, okay, and d, okay, 1 3, d23, d33, okay. So this is the your adjoint of a, okay. So this is your adjoint of a, and as you know, see, a inverse equal to adjoint of a, okay, divided by determinant of the matrix, okay. Now, okay, see, now x equal to a inverse into b, okay. So x is your dx dy d lambda, okay. So this equal to your a inverse, okay, means d11, d21, d31, d12, d22, d32, d13, d23, d33, okay, divided by value, determinant value of the matrix, and multiplied by the b, that is lambda dpx lambda dpy minus dm plus x dpx, okay, plus y dpy, okay. So this we can also write as d11 by d d21 by determinant of the matrix d31 by determinant value of the matrix d12 by determinant value and d22 by determinant value, then d32 by determinant value, d13 by determinant value, d23 by determinant value, d33 by determinant value. Okay, and multiplied by lambda dpx lambda dpy, okay, minus dm plus x dpx plus y dpy. Okay, so now we will calculate, okay, the value of dx dy and d lambda separately. Okay, so first we will calculate the value of dx. Okay, so dx equal to, so this becomes d11 value of the determinant multiplied by lambda dpx plus d21 by determinant value multiplied by lambda dpy plus d31 value of the determinant multiplied by minus d plus x dpx plus y dpy. Okay, so this equal to d11 by into lambda dpx, okay, plus d21 by determinant value multiplied by lambda dpy plus d31, okay, by determinant value multiplied by minus dm plus x dpx plus y dpy. Okay, so this equal to, here we can take 1 by determinant value as common, so we will get d11 lambda dp, okay, x, okay, plus d21 lambda dpy plus d31 minus dm plus x dpx plus y dpy. Okay, so this is your equation number 7. Okay, now we'll calculate the value of our dy. Okay, so dy equal to d12 by determinant value multiplied by lambda dpx. Okay, so this equal to dy equal to, okay, d12, okay, d12 by determinant value multiplied by lambda dp, okay, x plus d22 determinant value multiplied by lambda dp, okay, y plus d32, okay, d32 by determinant value multiplied by minus tm plus x dpx plus y dpy. Okay, so this equal to d12 lambda dp, okay, x plus d22 lambda dp y plus d32 minus dm plus x dpx plus y dpy whole divided by determinant value. Okay, here we can take common as 1 by determinant value, taking as common. Okay, here we will get d12 lambda dp x plus d22, okay, lambda dpy plus d32 minus dm plus x dpx plus y dpy. Okay, so this becomes your equation number 8. Okay, then similarly d lambda equal to, okay, d13 divided by value of the determinant multiplied by lambda dpx, okay, plus d23 by value of the determinant multiplied by lambda dpy plus d33 divided by value of the determinant multiplied by minus dm plus x dpx plus y dpy. So see, we can write this. Okay, d lambda equal to this, and by taking 1 by value of the determinant as common, okay, this becomes d13 lambda dpx plus d23 lambda dpy plus d33 minus dm plus x dpx plus y dpy, and this becomes your equation number 9. Okay, rest part of derivation of Slutsky equation we'll discuss in the next video. Thank you. Have a nice day.